Hey guys, we're back with the notes for 9.3. Today we're going to be doing more graphing with rational functions, but instead of focusing on the asymptotes, we are focusing on discontinuity and holes. Okay, so we're still going to be pointing out those asymptotes, but we're going to show you what actually happens if you factor everything and then something cancels. Okay, so I'm not going to read you everything on this first page, but I want to focus on this problem right here. So if you'll pause the screen, copy what you see. Actually, I'm going to pause it this way. Pause the screen, copy what you see, and then we'll get started. Perfect. Okay, so let's say I factor my first problem, and I factor it out into x minus 1, x plus 2 on top, and x plus 2, x minus 3 on the bottom. We already know that anything that would make the bottom a 0, such as the negative 2 or the positive 3, would be called a vertical asymptote. But since these two pieces right here, let me highlight them, this guy and this guy, since they would technically eliminate, leaving only this part left over, x minus 1 over x minus 3, we actually say that that place, x plus 2, meaning that it is undefined at a negative 2, is our hole, okay? So that's our x that would not let us work. It canceled out on the top and bottom. So if we take that negative 2 and we plug it in now to our leftover equation, or the pieces that remain after we canceled out those factors, then we can find the y value. So again, this x is the solution that would cancel out factors. This is the y that we get from plugging it into what is left over. Okay, and I will show you 4 more full examples of that. Okay, but basically you're going to graph only the piece that's left over. So this would be what we graph. And when I get to the point, negative 2 comma 3 over 5, I would use an open circle to show that there is a hole there. It basically would look like we are going to, let me show you this real quick. It basically would look like whatever our graph is, hole, and then it just keeps going. Okay, if it was something quadratic, it would just go hole, and then you would keep going. Okay, so all you're doing is putting an open circle at that discontinuity. Okay, all right, moving on to the bottom. Remember that if your degree on top is ever bigger than your degree on bottom, that does make for a slant asymptote. This is the exact same problem that we worked out in the last notes. I just wanted you to have it to see one more time. Okay. All right, let's go ahead and get started with some examples. So example 1, I'm going to have you pause the screen, copy what you see, and then we'll get started. All right, so I have already started this problem with a little bit of information, so we can go rather quickly. First thing I did was factor out everything in the original problem. So here's my original. I factored the top into x plus 5 and x minus 2, and I noticed right away that this x minus 2 and this x minus 2 can eliminate. So remember, we changed the sign. That means I have a hole at a positive 2 comma something, okay? To figure that out, we are going to plug a positive 2 into what's left over, which is my x plus 5, okay? So if I do that, I would say 2 plus 5 equals 7. So 2 comma 7 is my hole. Right now, already, I'm going to go ahead and put an open circle at 2 comma 7. So 2, 4, 6, 7. Okay, that's where my hole is right now. The rest of it, I'm going to go ahead and find my asymptotes. So horizontal asymptote, it's degree, actually I'm going to change that because we simplified. It's not degree 2 over degree 1 anymore. It is just a linear line. So we actually don't have any horizontal asymptotes because all I'm worried about now is graphing this, like x plus 5, that's it, okay? So if I do that, x plus 5 doesn't have a horizontal asymptote. He's not a fraction, so he doesn't have a vertical asymptote. He's just a line. So let's go ahead and graph him. I did highlight in green on the table what your intercepts are. So what would make that top equal 0? A negative 5 plus 5 would make it equal 0. And then what happens for my y-intercept? If I plug in 0 for the x, I would get out a 5. So I should have an intercept right here on negative 5, 0, and right here on 0, 5, which makes sense because this is going to be a linear graph. So I'm going to go ahead and draw my line. Notice that when I get to that open circle, I am going to stop and go on to the next part, okay? Let's go ahead and focus on the domain. In this case, we have all real numbers except for that hole. So except for that x number, I have to skip over. So negative infinity, we have to skip over the 2. and then we can go all the way to positive infinity, okay? All right, if you need to pause the screen, copy what you see, that's great. Otherwise, let's go to the next problem. Perfect. If you'll pause the screen, copy what you see, we'll get started. Okay, I'm actually going to have you edit this horizontal asymptote part real quick, because instead of being degree 2 over 2, we are actually degree 1 over 1 after we simplify, okay? All right, let's go ahead and look at our first part. So if I worry about only the original equation, I factored it out. The top is the difference of squares, x minus 3 and x plus 3. The bottom factors into x minus 3 and x plus 1, which means this factor, x minus 3, eliminates off the top and bottom. That leaves me with x plus 3 over x plus 1. We do have a whole because we canceled something. That whole is a positive 3 for the x, okay? So we are going to take that positive 3 and we are going to plug it in to the problem that remains, okay? So the 3 plus 3 on top, 3 plus 1 on bottom gives us 6 over 4, which is 3 over 2 if we simplify it. So right now I'm going to go ahead and go to that point, 3 comma 1.5. So 3 comma 1.5. I'll put an open circle at him right from the beginning, okay? All right, we're going to check for asymptotes. So horizontal asymptotes, because I have degree 1 on top, and I'm only looking at this equation now, degree 1 on top, degree on bottom, that means I'm using a ratio of the leading coefficients. My leading coefficients are 1 and 1, so I have a horizontal asymptote at y equals 1. Let's go ahead and graph him. Vertical asymptotes I get by setting the bottom equal to 0. So if I did x plus 1 equals 0, I would end up with x equals negative 1 as my vertical asymptote. So let's graph him. I don't have a slant asymptote this time based on my degree. You would never have a horizontal and a slant. You'd have one or the other, okay? All right, so let's go ahead and get a couple critical points. I need 2 on the left side of my vertical asymptote and 2 on the right side. So we're going to plug in negative 3 and negative 2 on the left side, 0 and 1 on the right-hand side, just because those are the lowest numbers, they're easiest to plug in, okay? So if I zoom in, I've already plugged them in and written them out. So let's look at this. Negative 3 plus 3 is 0. Doesn't even matter what's on the bottom. That's going to be 0. That right there is my x-intercept, actually. So look at the next one. Negative 2 plus 3 is a 1 over a negative 1 gives me negative 1. 0 plus 3 is 3 over 1 gives me 3. That happens to be my y-intercept. And finally, 1 plus 3 is 4 over 1 plus 1 is 2. So 4 over 2 gives me 2. Let's go ahead and graph those points. So negative 3, 0. Negative 2, negative 1. And then we know to just follow my asymptotes. 0 is going to go to 3. 1 is going to go to 2. And then again, we're just going to follow our asymptotes. When we get to that hole, we're going to skip over him and move towards our asymptote, okay? My domain on this one, there actually is 2 places I need to skip. I need to skip over my hole, and I need to skip over my x-intercept, okay? Or my vertical asymptote, sorry. So I'm going from negative infinity. I'm going to make a skip. I can go between the asymptote and the hole and then skip. And then I can go towards positive infinity, okay? So my first asymptote that I skipped was at negative 1. The second place I skipped was at my hole, 3. I'm only focused on the x's right now, okay? All right, if you need to pause the screen, copy anything you missed, go ahead and do that now. Otherwise, we're moving to problem 3. Perfect. Go ahead and pause the screen, copy what you see for 3, and then we'll get started. All right, so again, I focus at the beginning. Here's my original equation. I factor the top into x minus 3, x plus 2. X plus 2 and x minus 2 are different, so nothing cancels on this one. That means on this problem, I have no holes, okay? I'm going to solve this just like we would have for 9.2, okay? All right, second thing I'm going to do is find all my asymptotes. Degree on top is a 2, degree on bottom is a 1, so we are going to need to do a quick little synthetic division to figure out what our slant asymptote is. So I'm going to come up here. I'm I'm going to write out my original. So 1, negative 6 is on top. Divided, change the sign, checking a 2. It's the opposite sign of this guy. Bring it down, multiply gives me 2. Add it, multiply it, add it, and we don't care about the remainder. So this right here is my slant asymptote. So remember that that is a y equals x plus 1. Okay, I'm going to change colors. He is going to be orange actually. There we go. All right, so if I graph my slant asymptote to start, we are graphing mx plus b, x plus 1. All right, let's look for a vertical asymptote. Vertical asymptote is anything that would make the bottom equal to 0. So if I set x minus 2 equal to 0, that would come out to be a positive 2. So I have a vertical asymptote at x equals positive 2. So I'm going to draw him this way. Beautiful. And there are no holes, which means I just need a couple points to check in on. Okay. All right. If I want to find my x-intercepts, that means I want any x's that would make my equation on top equal to 0. That would be the positive 3 that would change on top. That's this guy. And the negative 2. Okay. So right from the start, I should know that those two come out to be 0. Y-intercept would be if we plugged in 0, what we would get. I'm going to zoom in to show you that. So that would give me a 0, 0, negative 6 over a negative 2 gives me positive 3. So we have 3 intercepts already. We really only need 2 more points. So let's go ahead and plug in 1. 1 squared is 1, minus 1 is 0. So on top I've got negative 6. On bottom, 1 minus 2 is a negative 1. So 2 negatives makes that a positive, 1, 6. Last one, I'm going to plug in 4, just to give me 1 more point as a direction for my asymptote. 4 squared is 16, minus 4 minus 6 is minus 10, over, and there should be a 4 right there, apologies. There we go. 4 minus 2 is 2. So we've got 6 over 2 gives me 3. All right, let's go ahead and dot those points. So negative 2, 0, 0, 3, 1, 6. Okay, and I did skip negative 1. You could have plugged that one in also. You could check negative 3, negative 4, anything you wanted. I really am just trying to focus on my intercepts here and here, and then 1 other point to give me a direction. Okay, and it could have been whatever you wanted it to be. So if I go ahead and connect these and just focus on moving them towards the asymptotes. On the other side, we have an intercept at 3, 0, and 1 more point at 4, 3. So again, I know I'm moving towards the asymptotes, so I just focus on moving towards them. Okay? All right, domain. We have no hole, which means the only thing I have to skip over is that pink vertical asymptote. I'm going from negative infinity, skip over the 2, pick it back up, and go to infinity. Okay? All right, if you missed anything on this problem, go ahead and pause the screen, copy it down. We're going to do one more. We're almost there, guys. All right, if you would, pause the screen, copy what you see on number 4, and then we'll get started. Great. Okay, so I started by looking at my original equation. I factored out the top, pulled out that GCF of 4x. I'm left with an x plus 1. On the bottom, there's nothing to factor. So in this case, I have nothing to cancel, which means there are no holes. I have no discontinuity. The only thing I have are some asymptotes. Okay? All right, moving into checking those asymptotes. Horizontal asymptote is a degree 2 over a degree 1, which means that I'm going to need synthetic division to figure out a slant. I do not have a horizontal asymptote. So if I move up here, I write it out. I got 4x squared plus 4x plus 0, right? I need all 3 pieces, even though there's no constant. Going to divide it out. We do not know how to do a full synthetic division with this 2 out front, okay? So I'm actually going to show you this a little bit different way, okay? You can just copy it down for this one. There shouldn't be anything in your assignment where you have to do this, okay? But technically what we could do is treat it like long division. So I'm gonna write this out, 4x squared plus 4x plus 0. We're gonna write it out full on like long division from elementary school, okay? If I start with this one and I say 2x goes into 4x squared how many times? We would say 2x. Now we're gonna distribute this backwards. So 4x squared plus 10x, and we're gonna subtract. 4 minus 4 is 0, so there's nothing here. 4 minus 10 is a negative 6x, and we could bring down this 0. Okay, we would go one more time. We'd say how many times does this 2x go into negative 6x? And that would be a negative 3. So we're going to take negative 3 and distribute him to both. I have negative 6x minus 15. And again, we would subtract. Remember, if you subtract a negative, that's the same as adding. So I would do 6 plus 6 is 0. That's gone. And then 0 plus 15 is 15. We don't care about the remainder. My slant asymptote would be this piece right here, okay? And again, I want you to have that on your paper, but you would not necessarily have anything like that on your assignment or on a quiz, okay? All right, so slant asymptote is that y equals 2x minus 3. Let's go ahead and graph that real quick. So minus 3 is here, and we are going rise 2, run 1. All right, so there's my slant asymptote. Vertical asymptote is anything that would make the bottom equal to 0. So if I do 2x plus 5 equals 0, I would subtract the 5 and then divide by 2. So x cannot be negative 5 over 2, or if that's easier for you to say, do negative 2.5. So I'm going to run through this just so you know where I'm getting it from. Okay, but I'm going to say negative 2.5. So let's go ahead and graph him, going right between negative 2 and negative 3. And I really, really want to encourage you to extend this down a little bit because we are going to need some extra space down here in order to figure out where the rest of our points are. Okay, so I'm going to extend both of those asymptotes a little bit. There we go. All right, we are ready to find our intercepts and a few other points. So if I look at what would make the top equal 0, we would have a 0 from the GCF and a negative 1. So we know both of those should give us a 0. Okay, think about if you plugged in 0, we already have that one. So I'm going to need, let's see, negative 1, 0, and 0, 0. I have 2 points inside, but to know which way they go, I'm probably going to need one more point. Let's do negative 2. Okay, so if I've already plugged in the negative 2, so negative 2 squared is 4. 4 times 4 is 16, minus 8. And then on the bottom, we've got negative 4 plus 5, which is 1. 8 over 1 is 8. On the other side of the asymptote, since we're at negative 2.5, I went ahead and did negative 3 and negative 4. So let's run through these. We've got 16 times 4 is 64. Minus 16, and then negative 8 plus 5 is negative 3. All right, so up top we've got what, 48 over negative 3 is a negative 16. For the next one we've got, let's see, 9 times 4 is 36 minus 12. And then negative 6 plus 5 is a negative 1. So 24 over negative 1 is negative 24. Again, you can use the calculator to do all of this, but you are needing to check points, okay? All right, so let's go ahead and graph the last couple. We got negative 2, 8, 2, 4, 6, 8. That's way up here. That definitely means that if I'm following my trend, following my asymptotes, this is going to come turn around and slope back up. It also means that my other pieces are way down here, guys. So if this right here is at negative 8, probably going to be double that. So negative 16 somewhere down here. All right, so negative 3 is negative 24. It's even farther. And negative 4 is at about negative 16. So we're probably following something very close to that same idea, like this. Okay, I'll zoom out just a little bit so you can see it. There we go. All right, if you missed anything on this page, go ahead and pause the screen, copy what you need, and we are all set with the notes for 9.3.